Hi, this video is to talk about analysis of variance, also known as Anova. This is chapter 13 in our class, and what we are doing in this chapter, we're now comparing three or more populations and determining if they differ. What we're doing is we'll test for difference among three or more population means. Remember, in chapter 10, we are comparing two populations, the difference between their means. Now we have three or more populations and comparing to see if they differ. So we don't know, again, as a reminder, we don't know how the population is. So we're going to collect data and use a sample data to get the mean and variance and to come up with this test. So let's start with an understanding. What we are doing is we are going to have a hypothesis in Anova, and to test a hypothesis, we compare the variance resulting for a given condition, a treatment, to the variance resulting from everything else, what is called error. We're going to use a new statistic which is called F statistic. Remember, we have the Z statistic, the T statistic, and now the F statistic. The F statistic is used to compare the difference between population means, which is Anova. So this is the hypothesis, and that's the only hypothesis we have. No hypothesis that the means from group 1 is equal to the means of group 2 is equal to the means of group 3, and so on for how many groups we have. And the alternative hypothesis is that these means differ. Okay, if we reject the null hypothesis, we cannot conclude that all population means are different. Rejecting null hypothesis means that at least two population means have different values. Okay, one important let's say background is the terminology that you need to understand. Some of the problems talk about factors, some of the problems talk about treatments. So let me explain what a factor and treatment what they are. A factor is a variable that the experimenter has selected for investigation. I'm going to give an example in the next slide. A treatment is how much this factor vary. Okay, the experimental units are the objects of interest in the experiment, and the response unit is the variable of interest that I'm looking for the means and comparing. Let's take a look at one example. Chemitech experiment. Chemitech is a company developing a new filtration system for municipal water supplies. There are different methods that can be used to assemble the system. Chemitech has narrowed down to three methods, A, B, and C, and wants to determine which assembly method can produce the greatest number of filtration systems per week. So we have three methods. So these are the different, let's say, factors. I'm sorry, treatments. Okay, the treatments. I have three methods, three treatments, and the factor is the filtration, the assembly method. Okay, the assembly system. So assembly system is the factor that this is the variable the company is using to change the potential results, which means the productivity. Okay, so I'm gonna use different assemble systems. Okay, talking of in terms of treatment, how is the treatment? So I have treatment A, treatment B, and treatment C, which is assemble method A, assemble method B, and assemble method C. Okay, and I want to determine. So for the purpose, is selected 15 workers, and they randomly assign each of the three treatments to 5 of the workers. So factor is the assembly method, treatment is ABC, and experimental units is the employees. The response unit, what I'm interested is the number of units produced, which means the productivity. And I want to see if the mean number of filtration systems under method A is equal to the number of filtration systems produced under method B, which is equal to the mean number of filtration systems produced under the method C, or if they differ. So basically this is what we're doing. Okay, let me give you another example here. This I show in my classes. Imagine I can split our class in three groups. Okay, the first group is going to use only Excel to solve the problems in statistics. The second group is going to use Excel, half Excel and half by hand or calculator. And the third group cannot use Excel, only using the calculator. Okay, so I split the three groups. So my factor is using Excel. Okay, use of Excel. Do the use of Excel increase the mean grade? And my treatments are entirely Excel, half Excel, and no Excel. Okay, so these are the different treatments I'm giving to different groups, and then I get students' mean grade, and then I see if they're equal or different. Okay, we could see more examples. I'm gonna go over one more example on Mind tab, so we don't spend too much time on that. This is chapter 13, analysis of variance in the completely randomized design. So I'm going to click here. Let's take a look at some problems, and then I can tell you what treatments are and what factors are. Let's take a look at this one. 3 different methods for assembling a product were proposed by industrial engineer. So we know that the engineer is proposing methods for assembling a product. So the factor is the method to assemble the product. The treatment is the 3 different methods. Okay, let's take a look at another one. To study the effect of temperature on yield in a chemical process, 5 batches were produced at each of the 3 temperature levels. Okay, so we have a table here, and then I can see that my factor, the variable that I'm analyzing the effect. So I want to know if temperature has an effect on yield. Okay, so the factor is temperature. The levels are the different 50, 60, and 70, the different levels of temperature that I have. Here, one more, and that's it. Auditors must make judgments about various aspects of an audit on the basis of their own experience, indirect experience, or combination of the two. So you see that we have the levels here. These are the treatments, which is also here. They're direct, indirect, and combination. So the variable here is use of judgment, make judgments. And here is the 3 levels of treatment. Okay, so let's go back to here and see if I can all right, let's stop here, and I'm going to prepare another video about more details on terminology and math on Anova.